Hi guys, I am continuing now with my Hypocycloid construction. In a previous demonstration I did the Hypocycloid, and now I'm going to do the Hypocycloid. I am going to do this Hypocycloid without attaching it to the Hypocycloid. In the past what I used to do is do both cycloids together, but I decided to do them separate so that you guys can see the construction better. So first thing, I'm going to create a curve of 70 millimeter radius. So this curve, will come around here, and this is what our Hypocycloid would be rolling on. Actually, I'm going to just carry the circle up slightly. I think that's a bad location, so I'm just going to go right here. Yeah, this gives us more space to work with. So O is my axis. I'm just setting up as to where my circle will start. So my inner circle will start right here at this point. I'm going to make my inner circle radius 20. Inner circle radius 20. That's a nice circle in there that we all can see where it's going. Now the next thing we are going to do is divide the circle into 12 segments. So far it's already divided into 2. And now let's get to it. Divide this into 12. And this process will be done using our 60-30 set square. Hope you guys are still following and we're getting through smartly. So now the circle has been divided, and here's where we're going to label. I usually start at 12. Some people start at 0, but I start 12. 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and back to 12 or back to 0, depending on how you look at it. From here now, we need to put in our radial lines coming off of these points that I've just placed in. So 6 is going to be a point by itself, and 6 is going to be our lowest point. 5 and 7, they are going to create one radial line. 8 and 4 together create one line. 9 and 3 together create another line. 10 and 2 create one. 11 and 1, they create one line themselves. And 12 is a single line. What I'm going to do is I'm going to put in the center, the axis of this circle, and I'm just going to dash in where that would be. So this is the center line for that circle. Okay. So what we need to do now is we need to divide this surface here, this curve line. We need to divide that into 12 pieces. And we are going to take the distance between 12 and 1 as our division interval. Okay. And we are going to divide this on our top line. So that's our first point. 2, 3. So what I'm doing is I've taken the interval and I'm then just marking off 12 equal spaces on this top line. Just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I'll label these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's my 12 points there labeled. Now, what I'm going to do, I'm going to draw a line from 0 going through each point. Sorry, from O, which is the axis of the larger circle. Hope you guys are following and you understand this so far. Okay, so let's see before we go any further what we have done. We have created our curved circle, our curved surface that our circle is going to be traveling on, and that is radius 70. This inner circle is radius 20. We divided this circle into 12 pieces, and then we divided from the start to where it's going to finish into 12 pieces also, using the same intervals to determine our 12 pieces. What's the next step now? Oh yeah, I created radial lines from our division points. So I'm supposed to have 7 radial lines if we look here. 1, 2, 3, 4, 5, 6, 7. Now, the final step is that we need to plot this. To plot this, we are going to take the radius. I'm just re-emphasizing this circle, guys, before I go. So now I have the radius here, which is 20, and I'm going to go down each point and plot. Now this is all confusing. Let's say it's confusing, and a lot of students get confused here at this point as to how do we start this plotting. What I usually suggest is to start at 6. The reason why we start at 6 is because 6 is the center, and we always know the center where that's going to be. For this point, for this curve, we are creating an epicycloid. The curve is going to go in this general direction, starting at 12 and going to a high point at 6, or sorry, the lowest point at 6, and then back to a high point at 12. So I know 6 is my lowest point, so I'm going to come here on my dash line and put in 6, which is my lowest point here. So once I have in my lowest point, which is right here, I know I can find all the rest. So I'm just going to go to the left, so I'm going to go back now from 6 all the way to 0, going down the scale. So now I go to 5, and at 5 we know that 5 has to drop down one line right here, and at each interval we are going to drop one line down. So 5 connects with the line 7 and 5. Now when I'm on 4, 4 is going to interact with the line 8 and 4 here. That's one step down. Then when we go to 3, at this point it's going to interact with the line 9 and 3, taking another step down. And then when we go to 2, that is going to interact with the line 10 and 2, taking another step down. And we are at 1, and 1 corresponds with the line 11 and 1, which is here. And then on the axis where we started corresponds with 12, which is our lowest point here. So we have plotted half the curve. Now let's plot the other half. So now where were we? Now let me just highlight these points that I'm going to, so that you guys at home can see. Now 6 is here, 7 will be here, we will stop there. These are the stopping points that I'm just dotting in, so that you guys can see where I'm going to start. So we have stopped 6 already, so I need to go 7, 8, 9, 10, 11, 12. And like I said, 6 is the lowest point, so 7 would be coming in somewhere on this line, 8 on this line, 9 on this line, 10 on that line, 11, and then 12 back to that point. So let's go. 7, put it in, 8, drop down 1, 9, drop down, 10, drop down again, 11, another drop, and 12. Okay. So now all that's left is for me to just plot this. Taking my time. And that is my curve here. And this curve is called the Epicycloid. And the Epicycloid is the curve that runs on the inside to the curve, to the base curve, which is on the outside. So this is our main curve. This is like the track that this circle is running on. And this circle is running on the inside. Whereas the the Epicycloid runs on the outside and the Hypo runs on the inside. I think I just confused myself. So I'll just label this so that I don't confuse anyone. This is the Hypocycloid. Thank you guys, that's a wrap.